Okay, now stop passing over to Xue, yeah? Xue, you get this turn. Okay, you just put aside later that you're talking. Okay, I start. 1, 2. Now yesterday you told me that you all wanted to continue with my ice cream 6 selection, right? Okay, so how shall we do this? Okay, so if I were to ask a question, sometimes if I direct the question to a person without picking my ice cream stick, that person will answer my question. Okay, but if I were to pick my ice cream sticks, okay, then we will stick with what we did last year, okay, whereby that person will then say my call, understand, likewise left, right, front, back. Okay, we go with these rules because just now the other class want me like everybody around, and like not possible. Okay, so we just do front, back, left, right. So if I say call Colin, then Rose, Ziyi, Xingru, and Juicy has to set up. And Colin also has to set up. Okay? That is if I pick an ice cream stick. Think about it. We good? Understand? Zach, you look very confused. Okay? Okay, huh? Okay, let's continue. Let's do that practice now for, this is in your textbook, page 40. The meaning of the different inequality signs, okay? Okay, we know that this is the symbol for more than, this is the symbol for less than, this is the symbol for more than or equals to, okay? And then this is the symbol for less than or equals to. In fact, critical that you are able to translate the symbol form into worded form in your mind as you read a sentence. Because if you're not able to do that, you will find that it is difficult for you to translate any word problems into an inequality form. Okay? So learn how to read it like how I will read this inequality now, which is 5 times 3 plus x more than or equals to 9. Okay? So you need to learn how to read words as you read a mathematical statement. Then yesterday we also agreed that if I were to plus, minus, times or divide a positive number, okay, my sign, does it flip? What did we learn yesterday? Does it flip? It doesn't, right? Okay, no flip. It remain the same. No change. Whereas if I were to multiply or divide by a negative number, okay, we notice that there will be a flip of the inequality sign. So this is a quick summary of what we did yesterday. So looking at question 1a, which asks us to solve the inequality, no need to draw your number line, the question did not ask for it. So with this, okay, what will you do first? Okay, what will you naturally do first? Let's test out whether you know my game rules. Okay, Francis. I think Asher will be this. Okay. So Asher, can you tell me what will you do first? Cross or divide? Extend. Okay, so what do I write? Nice. Okay, great. Alright, so Asher has chosen to expand it. Would anybody propose a different method? Anybody has an alternative? You okay with this? Yeah? So that's great. If we all work, think the same way, then okay, we will continue with this technique. So 15 plus 5x more than or equals to 9. Next step, you will have to bring the 15 over to the other side. Okay? 9 minus 15, that will give us a negative 6. Or you tell me same, keep the same, okay. Keep the same, okay. Then negative 6 over 5. Okay, negative 6 over 5. You agree? Yeah, the inequality sign doesn't fit, right? Okay, so because we are only dividing by a positive number, so we must be cautious about what is it that we're dividing. It is a positive number, so no change in our inequality sign. Okay, it's either you need to answer this way in the improper fraction, or you can write it in a decimal or mixed number. They are all equivalent, so negative 1.2. Okay, that's fine as well. Okay, questions? Right, next. Okay, next we look at part B. 1 over 3 more than y plus 1 over 2. Okay, so we have fractions over here. Right? Now, when we do our cross multiplication, what was our conditions for cross multiplication? Both sides must be fraction, right? And what else? We must have a single fraction on both sides, right? Okay. Maybe I'll use a heart shape and maybe a rectangle. Okay. What's the thing that must be in between the fraction? It's an equal sign, right? Okay, it must be equal sign. Right? So in this case, is it equal sign? No. Okay? So we actually cannot do our cross multiplication. We keep our cross multiplication only to equations. Okay? We don't do it for inequality. The reason is because, okay, I'm not sure how is it that you go about doing a cross multiplication. I do not want to confuse this concept. Okay? So we keep to the idea that we're trying to balance both sides of the inequality. So we wanted more than y plus 1 over 2. If I want to remove the denominator, okay, I want to multiply by 3 on the left, 3 on the right. Correct? Because when I multiply by 3 on the left, I will get 1. Multiply by 3 on the right, I will get 3 times y plus 1 over 2. Okay? But if I want to remove the denominator of 2, I will need to multiply by 2 on the left, 2 on the right. So that will give us a 2 over here. And then this one doesn't have any denominator. In fact, I can go very quickly from this step directly to this step. Okay? How would I do so? Multiply by what? 6. Okay? If I multiply by the lowest common multiple of 6, okay, I can directly just jump into this one. So this is the LCM of 2 and 3. Okay? Rather than to multiply by 3 first, then multiply by 2. In fact, you do see that it's similar to cross multiplication, right? Okay? It does seem like, I cross here. Okay? Yes, you're not wrong, but I am very worried that you cross it differently. Okay? Whereby you end up writing 3 times y plus 1 on the left, more than, and after that, times 1, right? Okay? If you cross in a different manner, right, you may end up getting this, which we can clearly see that this here and this here are different. Because in this statement, 2 is greater, whereas in this statement, 3 times y plus 1 is greater. Okay, so I do not encourage you to think about cross multiplication when it comes to an inequality. Okay, we stick with the idea of multiplying by a lowest common multiple on both sides. Okay. Right, then from here, okay, in our next step, what will we do? Let's call a name. Plate. Plate right? I say that if I call your name, you also need to stand. negative 1 more than 3y. Click first. Okay, tell me what to write first. 3y smaller than negative 1. Okay. Then y. Okay, negative 1 over 3. Okay, so this is what Evan proposed. Okay, so 3y less than negative 1. Why did he do that? He just wanted the subject on the left. Okay, so it is actually the same inequality. Okay, this statement is the same. You'll see that it's the same. Okay, no problem. Alright, then after that, from this step to this step, we divided by a positive 3 over to the right. So we get y less than negative 1 over 3. Okay, of course, maybe some of you at this juncture, you are already thinking of negative 1 divided by 3. When you bring the 3 to the left, then your inequality sign will be more than over here. Then it's a 1. Okay, this statement and this statement, they are equivalent. Okay, y is still the smaller one. Okay, do you agree with me? Questions? Okay, so that's part B. Next, we look at part C. Okay, I got 1/3 z plus 1 plus 2 less than or equals to half. Okay, yes. Okay, give us. Okay, do you have the confidence to try this on your own first? Can we do that? Okay, maybe please try this on your own. I give you about 3 minutes to do it. Okay, everybody's final answer is the same actually. Z less than or equals to negative 5.5 or 11 over 2. They're all the same. Agree? Okay. Now let's look at the working that we presented. Okay. Okay, so let's look at this one here first, okay, for Katie, right? What she did was that she expanded this. How many of you actually chose to do expansion? Did all of you decided to do the expansion? Okay, I think we all saw it amongst all your friends over here. They also all decided to expand. Right? Nothing wrong with that, but later on I want to show you, okay, what if we don't expand? Okay? So for expansion, this is what we get. Then after that plus 2, then less than equals to half. Okay? Then following that, 1/3 and 2 was brought over to the other side. Okay? Simplifies to negative 1 and 5 over 6. So z is equals to how this was actually arrived is taking negative 1 and 5 over 6 divided by 1/3. Or simply times 3. Okay? It's either taking it this way or times 3. Right? So this is for this step over here. This step working. Over here, okay, what Rose has given us, also an expansion, also brought this to the other side, simplified, okay, and actually it's exactly the same step. Right? Any questions? This step working. Okay? Then for Emmanuel, right, also did an expansion, but something different that he chose to do was that he wanted to kind of remove the denominator and he decided to multiply by 6, which is the lowest common multiple of 3 and 2, which are found in the denominator, across the entire inequality. And that is fine, okay, as well. So 1/3 times 6 will get 2, 1/3 times 6 I'll get 2 here, 2 times 6 I'll get 12. Okay, just got to make sure that we multiply properly, okay, and then this step is right. Then we shifted the 2 and 12 to the other side, okay, and then we get z less than or equals to negative 5.5. Okay, any questions that you want to ask for this set of things? So everybody presented this, did it well. Okay. Now I wanted to just ask, yes, can you let me do this first? Okay. An alternative that I want us to learn, because I know that some of you may struggle due to the expansion resulting in a fraction. Okay, so what we actually do? So we wanted z plus 1 plus 2 less than or equals to half, okay, you can bring this plus 2 to the right side. Okay, such that we get this half minus 2 is negative 1 and a half. Okay, instead of doing the expansion method, what you can do is that, notice that this is 1/3 times z plus 1. Okay, so if I want to bring the 1/3 over to the other side, I can divide by 1/3. Or alternatively, you see as multiplication of 3. So I can have z plus 1 less than or equals to negative 1 and a half. Okay, divide by 1/3. Okay, and that will allow us to get z plus 1 less than or equals to this times 3. This is negative 3 over 2 times 3, negative 9 over 2. So that is negative 4 and a half. Okay, then we can have z less than or equals to negative 4 and a half minus 1, which simplifies to negative 5 and a half. Okay, so this is an alternative, which I want us to be equally skillful in, so that you know how to overcome, right, based on how you decided to work this out. Okay? Okay? So up to you in terms of what you're comfortable with. But so long as whatever you decided to do, you must know how to overcome it. Okay? You must have this set of skills. Questions? Alright, thank you. Okay? Next we look at practice now 4. Inequality means that it is part of this inequality over here, it is one of the solutions. Okay, we know that whenever we solve an inequality, there are many solutions because it is an entire range of values to look at. So for example, just now we saw that the possible solutions is anything that is less than or equals to negative 5 and a half. So it could be negative 6, negative 7, negative 7.2, negative 999, okay, any of those numbers. Okay. Then the question asks over here for you to find the largest possible, okay, value of p, and p must be a perfect square. Okay, so that is the requirement of this question. How we go about solving this? We just do our usual way of solving. Okay, solve this set of inequality first. Determine what is the final answer. Then we decide and look for the largest perfect square. Okay, so would I give you also another 4 minutes, okay, to try out this question? Alright, somewhat similar to what we did earlier on already. Just be very careful if you're doing. Okay, 4 minutes the largest possible value of p. Do you have an answer? Don't have? What about the rest of the group? Any answer that you managed to get for the p value? What did you get, Yasha? 4. Okay, so let's just wait out. It was 4. Okay. Okay, everybody got it was 4, but we noticed that the way they solved the inequality is different. Correct? Okay. Let's start off with Zayden's one first. Okay. Now, what did he exactly do? Okay, we have half minus 3/4 times p minus 3 more than -1. Okay, he did multiple steps here. He first took this half, this positive half, brought it over to the other side, which explains why we get this negative half here. Okay, so that's one thing that he did from the first step to the second step. Okay, concurrently, he also took this negative 3/4 and multiplied inwards in my expansion. Okay, such that you get negative 3/4p plus 9/4. Why is it plus? Because minus and minus becomes a plus. However, I take issue with how he presented it on the whiteboard. It might be just a problem with whiteboard. The p is too low. It looks like it's with the denominator. Please write your p, okay, beside the fraction, otherwise on top on the numerator, because it suggests a different thing. Okay, so like that, it's not the same as like that. Okay, but this is the same as this. Okay, so because this is 3/4 times p, so times p means times p over 1. So numerator times numerator, denominator times denominator. Okay, so it's either you write the p in the center, okay, beside the fraction, or else directly place it into the numerator. Okay, based on this handwriting, it looks like it is in the denominator, which is a totally different meaning. Okay, so I will change that so that we don't get that confusion. Okay, so now, right, from here to here already done. Okay, he got negative 3/4p plus 9/4 more than negative 1 minus half, which simplifies to negative 1.5. Okay, then what he did is that he took this positive 9/4, bring over to the right side, becomes a minus 9/4. Okay, so this step is also done. Right? And then he noticed that there's fraction, it doesn't like it, it wants to get rid of the denominator. Between the denominators 4 and 2, lowest common multiple is 4. So he multiplied by 4 on both sides, such that he gets negative 3p here. Negative 1.5 times 4 is negative 6, minus 9/4 times 4 is negative 9. Okay, he could have simplified this first before multiplying by 4, but this is also fine. Okay, minus 6 minus 9, okay, then from here to here, what he did was to actually divide by negative 3 both sides of the inequality. I don't know why you don't want to simplify first. Okay, you can just simplify. Minus 6 minus 9 is negative 15. Okay, but he didn't. So by dividing by a negative number, it caused the inequality to flip to become a less than sign, which explains why negative 6 divided by negative 3 is 2, negative 9 divided by negative 3 is a positive 3, right? Positive 3, correct? Yeah. Okay. So that's the problem. Okay, so you would have you have avoided the problem if you just simplify. Minus 6 minus 9 becomes negative 15. Then you wouldn't get that problem anymore. So down here the problem is that this is a 2 plus 3, not a 2 minus 3. Okay, so this inequality should be p less than 5. Okay, and not p less than negative 1. Okay, so are we okay with this step of working? We clear? Okay, the p equals to 4, I'll come back to it later on. We look at solving of the inequality first. Okay, next we look at what Hansheng has done. Right, he did something similar. He brought this half here over to the right, hence getting negative 1 minus half, okay, which is negative 1.5. Okay, in this case, what he decided to do was to place the p minus 3 on the numerator, which is the right thing to do, which is what I explained here. Okay, then after expressing it as a single fraction. Okay, the minus sign stays outside of the fraction. Okay, so to take note about how he presented it. Then from here to here, he expanded 3 with p and 3 with 3. Okay, 3 with 3 is 9, right? Okay, wait, continue. Oh, wait. You expand and you times 2. Correct? Okay, so he expanded it and then he times 2 because negative 1.5 becomes a 3. So a few steps being skipped. I hope you can catch what he was doing. Okay, So it times 2, then this 3 times 2 becomes 6, right? Then expand becomes 6p, and then minus 18. Are we okay with this so far? Can? Okay, then from here to here, okay, it actually multiplied by 4, multiplied by 4. Okay, at this juncture, you may notice that originally this is a minus sign. It became a plus. Okay, I want us to understand why that is the case. So, how this is being interpreted is that it is a negative 6p minus 18 over 4, which essentially is the same as minus bracket 6p minus 18 over 4. Because this negative sign is for the entire numerator. It is not just for 6p, it is for everything on the numerator. Okay, so when you multiply by 4, okay, to this fraction, it actually becomes a negative 6p minus 18 upon multiplying by 4. Okay, I'm not going to write equal sign here because they're not equal. Okay, so you multiply by 4, it adds up to become this. And this is actually equals to negative 6p plus 18. Okay, so that is the reason why this becomes a plus. It is not a minus sign. Okay, questions? Alright, then after that, we get a negative 12 here. Then this plus 18 bring to the other side, hence we get p less than 5. Okay, any questions? Right? Okay, I really don't want you to go away from this lesson thinking that I just focus on what I know how to do and everything. There is value in looking at what your friends do and expanding, okay, your methods of solving. Right? Especially if you are going to do A math next year, okay? A math is going to be very algebraically challenging, right? So you must have that full suite and be able to adapt to different kind of methods, okay? Such that you can observe why is it that things happen, right? If there's no questions, we move on to the third way of doing okay, what 18 has presented, right? So she did something similar. Put the p minus 3 in the numerator. Okay, half on the other side. So similar to what Hampshire has done. Okay, then after that, the negative 3 over here is being expanded inside such that we get negative 3p plus 9. I suggest that the lecture line really draws slightly longer to cover, okay, all the necessary things. Okay, so that you don't lose out anything. Then from here to here, it is a multiplication of 4 on both sides, hence getting this and arriving at p less than 5. Okay, so this one is also straightforward, right? Really again, up to your habits, up to your preferences, we must know how to adapt, okay, to exactly what you have done. Okay, yes. How to get p was 4, I haven't come to that yet, okay? So we agree with all the solving, p less than 5. Okay, so what Hampshire actually gave us also is a number line. Okay, so he represented p less than 5 into a number line. Although the question did not ask for it, it is helpful for us to answer the question. Because with the number line, I know that my numbers, okay, that satisfy this inequality is everything lesser than 5. Okay, and I know that the next integer that is lesser than 5 is 4. Okay, then after that followed by 3, 2, 1, 0, negative 1, negative 2, and so on. Okay, question wants us the largest possible value of p. So the largest one must be the closest to 5. Okay, alright? And then we want the perfect square. I hope you remember what is the perfect square. Example of perfect square is 1, 4, 9, okay, 2, 3, 4, 16, 25, and so on. Your 1 square, 2 square, 3 square, 4 square, 5 square. Okay, so 4 is actually a perfect square. So it is actually the largest possible perfect square. So that's the reason why, okay, p equals to 4 is the answer. We understand it? Questions? Okay, so for all the attempts, okay, I will give 10 points. Okay, although I think we need to differentiate a bit because Satan's answer wasn't exactly correct, okay, in terms of the solving. So 5 points. Okay. Tuesday, but there's already one week on Tuesday, right? Okay, 29 is Monday. But I don't see you on Monday next week, right? Oh, okay. You are very lucky. Okay. Wait, this one I'll change it to Tuesday because I will see you on Tuesday. Okay, this one due on Wednesday, okay? But Wednesday, you're going out for learning journey. It's a 40-minute lesson. Okay, I'll miss you for 20 minutes. Alright, so better make sure you